You make a bunch of noise out here, so they have peace and quiet in here. Because there's no better sound than the squeak-free guarantee from Advantech Subflooring and Advantech Subfloor Adhesive.
Hello, America. We're rocking the podcast channel from the Atlantic to the Pacific here at the UnBuild It podcast. Yeah. Steve Basic with my good friends. Well, let's just say friends. Peter Yost and Jake Bruton. What's up, gentlemen?
I'd love to be qualified that way. That's tear trickling down my cheek.
Well,
I'm gonna push back and say, don't say just America. We have about 10 to 15% of our listenership is abroad.
Oh, wow. Yeah, like part of our 2.2 million viewers.
And I realize we have to qualify here generationally. Abroad means overseas, not a woman, Pete.
Yeah.
See, the terrible thing there is you now implicated me as part of this. Whew.
All right, you ready? We're talking.
Please move on.
We're
going Q&A again today, right?
We're going Q&A today. And this comes straight from MT.
We should say questions at unbuilditpodcast.com. This is like our thing now is answering questions because the questions we get are amazing and they are great topics for discussion and they lead us into good episodes. So keep sending questions because they're good to answer.
You know, one of these times I think we should do an episode of like the things we talk about in between episodes because we were just sitting here, Jake and I, and Pete was telling us when he visited the construction site of the Hoover Dam back in the day. 1930 and saw it under construction with his, they took a little field trip from the parsonage and headed on out. So.
I'm pretty sure this is the first time parsonage and the Hoover Dam have been connected in the same sentence.
But anyways, we're moving on. I know you want to talk and make this all about you, but we actually have to answer this question from good old MT. You know what MT is? Montana. All right. So I live in northwest Montana, somewhere in northwest. My typical insulation system is a 2-inch closed cell spray foam with an R13 fiberglass bat in the wall. So I'm assuming he's doing a 2x6 wall with 2 inches.
And not just mashing it in.
And not just mashing it in there. I'm doing a condition attic R60 spray foam with at the bottom of the roof sheathing. I'm assuming that's closed cell with cut roofs, and I have found this helps with his ice dams. So he's having some success there.
We should also note that you're editing this for brevity.
Yeah.
Yeah. Okay.
Thank you. So he's looking to start incorporating some exterior insulation. He likes the idea of zip R, but he's not sure about the minimum thickness I should use in my area. I'm a little nervous about condensation that could happen if I too use too little an R value. Do I think zip R is a good solution in this zone? And if so, what thickness do you recommend? Or do you recommend a more traditional exterior insulation?
So what is whitefish? Climate zone 6 or 7?
I never said whitefish. Now you just exposed where we're talking about.
You haven't said Paul's name yet.
We haven't said Hello, Paul, by the way.
Whitefish is small enough. There's only one guy named Paul who's a builder.
Paul and whitefish.
Is it 6 or 7? I didn't look it up. I'm guessing it's 6.
I'm guessing it's probably 6.
I think it's probably 6 unless whitefish goes up in altitude. If it goes up wise, it might be 7.
Okay.
But
either way, they're close.
Pretty cold.
It's freaking cold. How's that?
Yeah.
Probably pretty dry, too. No?
Probably 6B. Yep.
Yeah. I mean, Montana is drier than most.
Yes.
I think. So, all right. Excuse me. So, what do you think?
Well, the code is a bit of a help. I don't know what the code is in Montana.
They use the IRC.
And so there's a table you can go to not get into the whole first condensing surface temperature physics of it, but just go with what the code recommends as a minimum. And I think the code for climate zone 6-7 is going to be about 40% of the R value being on the outside continuous exterior in that range.
Would have been nice if we pulled up the code before we started, but I'll do it while we talk.
Okay.
So 40% of the R value on the outside.
Approximately. And so that means that you're using an air permeable insulation in the cavity, right? Because the whole idea of requiring 40% on the outside approximately is that you're warming the surface enough because you've got an air and vapor permeable cavity insulation.
So let me ask you this question. Let's keep this super simple for Paul.
Okay.
All right. He builds a 2x6 wall. He sprays 2 inches of closed cell, fills the rest with an unfaced fiberglass bat. What if we simply add R6 to that assembly?
Continuous to the exterior.
Yes. Zip R6 specifically to that assembly. And then we spray 2 inches of closed cell and then add an unfaced bat.
Yeah, that's actually, you tried to do that to be more simple, right?
Well, he already has a group, I'm assuming, as he says it's his standard wall. So I'm saying, okay, how do we take our standard wall and answer the question of how do I increase performance?
Okay.
Using a Zip R product.
So the first thing is that the first condensing surface is not the structural sheeting.
Right.
It's the inside face of the spray foam.
Yes.
Yeah. So the first consideration is that it's not just the R6 on the outside that's warming the whole thing. It's including the closed cell spray foam.
Yeah, and I mean, I like to look at it as where is vapor stopping? Right? It's stopping at the closed cell.
Yep.
So if it's going to condense, it's going to condense on that surface. And if we have 2 inches of closed cell plus R6 on the outside, then we're effectively at somewhere around R19.
So the interesting thing about this is that when you add that R6 to the outside of the structural sheeting, the code doesn't say anything about the drying potential of that sheathing, right? Because if you have a vapor impermeable or very low vapor permeability spray foam 2-inch flash to the inside, that R6 on the outside, its vapor permeability becomes pretty important in terms of you want that sheathing to dry to the outside.
But if I put a regular zip on the 2x6 wall that he's currently building, and then I put zip R6, the drying rate of the 7/16 panel is the same, except for a little less energy is getting out there.
Well, you're saying you have a structural half-inch
No,
OSB?
I am not. I'm saying remove that and replace it with zip R6.
Okay. Yeah.
Sorry.
So this gets into whether it's kind of right or wrong that Huber puts the structural sheathing to the outside of the assembly, because generally you'd like to have that rigid insulation continuous on that side warm that sheathing. And basically what you're doing is saying, I'm going to move that structural sheathing out and make it a lot colder, but it would never see any interior condensation because it's to the outside.
Right. Yeah. So one of the things that I think, and this is one of the problems I have when people talk about vapor and vapor barriers, is that they worry themselves, oh, where's the vapor barrier in this? Because they think that sheathing is always going to have something condensing on it. But
right.
If I'm not bringing moisture to that surface, then I'm taking it out of the equation.
Yeah, it gets tricky because we're worried about the moisture sensitivity of anything that's in that cavity or on the outside of that cavity, including the wood framing.
Yes.
But what we really, really worry about is if that sheathing is the first condensing surface. Because yes, some will condense on the very outside of the edge of the stud, but we're not worried about that. We're worried about what happens to the sheathing.
Yes.
This is why I am really happy that Huber is adding the recommendation for a rain screen to the outside of their Zip R panels, because if you make that sheathing colder, it really, really does need the added benefit of a airspace to dry and a space to drain. Because you've made that sheathing colder, you need to do a better job of protecting it from moisture.
Yeah.
but it's not getting that moisture from the inside. We're trying to improve how it handles moisture on the outside.
Yes.
Yeah.
With the rain screen.
Also smart on their part. If you're a manufacturer and you make something that can be damaged by water and you give it more drying potential in your recommendation, why not? Here's the code, by the way, for
6.
This is 2021 for 6. It's 20 cavity plus 5 continuous, 13 cavity plus 10 continuous, or 20 continuous.
Right.
And I went to 2021 because I'm assuming no one's adopted 2024 yet.
But he already has a cavity that is 13, 15. Is that 28? Right?
With the
2-inch closed cell and then
Yeah.
our 13 bat.
Well, wait a minute.
So it's our 26-ish.
Yeah, 26 is closer.
Yeah.
26.
Yeah.
So whatever I put on the outside, I mean, I'm going to add it to that 13. So 6 and 13, 19 versus 15. It's a 60-40 split in my favor. And you were saying that we only need 40%, at least 40% in my favor. Then we're at 60. So I think that's how I have done it in the past and how I would do it in the past. And in the future, should I go that route?
Well, so long as he doesn't have the sheathing trapped and not able to dry to the outside.
No, I'm saying
And with a
using
zip R,
zip
that's the
R
whole thing.
specific. Right. So in this case, zip R is on the right location.
So if he's asking, is it good to use the zip R panel in a cold climate? But he has the additional condition that if he wants to keep that 2-inch flash to the inside,
Yes.
now it's smarter to do zip R Huber because you're moving the moisture sensitive panel to the outside. If you did the rigid insulation to the outside of the structural sheathing,
And
now you've trapped it, right? It can't dry
Yes.
to the outside or the inside. So actually going to a zip R panel, if he keeps that 2-inch flash, is actually a better solution.
So if he takes out the 2-inch flash now, and then
Wait.
we put
Let's stick with that for a second because there's a lot of I've seen a lot of content online around you shouldn't use zip R in cold climate, which it's important to note that Huber doesn't recommend zip R for cold climate. And the reason they talk about it is the potential for air leakage and the potential for that moisture or that air driven moisture to get to the panel and cause issues.
You're saying that zip R, Huber does not recommend zip R for cold climates?
It's not in their literature for recommended for 6 and above, I believe.
Oh,
Yeah.
6 and above.
Yeah.
Okay. Yeah, that's interesting. I think
And-
we're going to do a little
And they
research on that.
They make the argument for that if you have air
I mean,
leakage,
one of their
you
plants
have-
is in zone 6.
Well, I think the good news is that if somebody has a question about this, I would start by calling the 800 tech line
Yeah.
and say, hey, here's my configuration, and let one of the engineers at Huber answer this question.
Yeah.
and there's a lot of murmuring in the social media community about the panel edges could get air leakage to them and things like that could cause they're susceptible to problems.
Huh, interesting.
And I think there's two important things to think about here. Number one, if you're using it as your structural sheathing, so that's zip R 9 and down, because the 12 doesn't qualify for structural sheathing because the panel's too far from the studs, you're blocking your panel edges. So I'm not sure what level of air leakage is getting to those panel edges if they're blocked or on a stud and fastened properly. And number two, you do what Paul's doing and flash it with 2 inches of spray foam, and then you've reduced the amount of energy that can possibly get to it ever anyway, that I wouldn't have any concerns using it in a
Yeah.
cold climate
I mean,
if we're
we've done that
adhering to
detail.
those ratios that we're talking about.
We've done that detail. I mean, it's a real quick way to enhance the zip R panel, right? You can use the zip R6, gives you effectively double the insulation value at the stud frame.
You know,
Right.
I've got a couple of projects where the additional question here is your climate cold enough that in addition to bumping the insulation up on your opaque wall, what about your windows?
Yeah.
Because, you know, I think in climate
Wasting
zone
time.
6 and above, you better be doing something that's at least R5 to be proportionate to what's going on with your opaque wall.
Yeah.
Because he's got R60 in the lid, so he's almost pretty close to the 10, 20, 40, 65 rule.
Yep.
So he didn't mention his windows, but that would be my next question as part of this.
What are they doing?
Part of this whole issue.
And that 2-inch closed cell, I know there's all kinds of people talking about it. Our insulators, for the most part, are very reputable, conscientious types. We've never used a flash of closed cell that didn't enhance the air tightness and enhance it significantly by, like, I'm talking 25 to 35% more tighter.
But you and
a very good house already.
You and I have been through this before, but you've got at least 2 insulating contractors that you have long history with of doing closed cell spray foam and doing it right. And they are never the lowest bid.
No, and they're never, yeah, exactly. So you have to pay attention to that. But yeah, I don't know. I have a really hard time with the foam argument, to be honest, because I've never really experienced major failure. We had one project that failed because we were using a soy-based, it was a new one. We were testing it out, and the surface was too cold.
Yeah, yeah.
And we learned that because it retracted from the surface. But other than that one time, I mean, we literally have hundreds of success stories in using it.
Now, you're also expanding your business to include, climate zones all across the United States.
Yeah.
What if you go into an area and you're working with a builder and he can't find a really good closed cell spray foam installer?
Yeah, and some of it is, we have established some new wall details that one has really taken off. We have one project under construction now, and I think we have 3 new, and it's funny because it's one of these things where we have 3 new projects that are going to be using a variation. And I say a variation because we've learned a lot about building that wall. So we're tweaking some things on these future walls. And then literally I just had a call Monday with a client and the builder, and we were talking about the wall, and I proposed the wall, and the builder absolutely loved the idea and said, it's a little bit more wood, but he's like, I think our framers and everybody will go a lot faster, and this will end up saving us money.
And what's the wall configuration?
It's a double wall, perfect wall.
Oh.
Where we put the air barrier in the middle of the wall. And we frame it on the frame a wall on the outside, on the inside. He said it's more framing, but when you see all these houses that have 4 inches plus of insulation on the outside, that is not easy. I'm doing a house right now. We have 4 inches on the outside, 7 inches on the roof, and I mean everything about it. The homeowner's like adamant about doing it, and it's like the whole time I'm drawing the detail, I'm like, this is just such a dumb idea.
Well, so
because it's so hard that the field of the wall is real easy. Okay.
Right.
The window is a challenge.
Oh.
The roof eave is a challenge. Getting some rake tails out is a challenge. Yeah. Getting the eave tails out is a challenge. There are so many hurdles in this that are just literally baffling.
I know we've been through this before, but in our Sion High Performance Builders Guild, this question of continuous exterior versus double stud, the back and forth. And a lot of folks just said, when you get thick enough on the exterior, it just gets really, really difficult, not only to get it designed right, but then to get it built right.
And I think that getting it built right is a lot tougher, because I don't think there's a lot of things that we assume, like the compression of whatever insulation we're using on the outside. Does it compress? Does it not? The cost of the friggin' screws.
Yeah, fasteners.
Yeah.
Like I was talking to the builder on this project. He's like, Steve, we're probably up at around $7,000-8,000 worth of screws for the wall and the roof. The roof has got to be, we're probably talking a 12-inch screw. And they have to find an 1.5 inches.
Yeah, that's crazy.
10 inches down. He's like, my roofer is going to just go ballistic when we try and do this. And I understand what we're trying to do, but I don't know. I've never done it yet, and I know we're way off track here, but I actually designed a roof outside of a roof. It was a remodeling project that we never built, but I would love to do that also. So you have like an existing rafter, and then you have a space and have another rafter system, and then just blow the whole roof, and then vent
So
on top
would
of
the
it.
outer ones be sleepers, not structural?
Well,
or-
we would have a roof on top of a roof and vent it. So it would be pretty complicated. I'd have to kind of give it a diet and trim it down some because it's complicated right now, but that's because I haven't really given it a whole lot of thought. But getting back to our good friend Paul, if you keep that 2 inches, we're good. And I think if we don't keep that 2 inches, then you might consider inverting the rigid insulation in the panel.
Speaking of his windows, if he's got that R6 panel and the windows are going to be installed, flanged to the outside surface there, do you do any sort of buck detail with an R6 panel, or would you just?
Not really, because they're still gravity loaded. So I do a detail where I'd use a rip sill. So the window can be gravity loaded on the sill.
I see.
And so the screws in the wall are literally just lateral holding.
So the whole bearing weight is on a structural
is
sill.
on the structural sill.
It is
that's
important
really
to note,
interesting.
though, I think, I don't know about Marvin, but I think Pella and Anderson both don't support leaving the foam in the Zip-R system for their flanged installs. You're supposed to omit the foam and put in wood blocking.
Put a buck in, basically.
Yeah, but
I
that's a
wonder
company
how they'd
that's-
feel about
That's
the bearing
their
being
spec.
to a sill, and then it's just the tipping that's controlled by the. That's really
But
interesting.
their thing is you're going to mush and make their window twist
Rack a
out
little
of
bit.
out of
Yeah.
plumb or out of square.
I
in
mean, the
some
beauty
way.
of the European window, you can't do that. If you wanted to install it racked, you couldn't. You can't.
You can't
They're
rack
just
those
so
windows.
robust. It's
That is fascinating.
It's good. Anyways, I think we've answered
Yeah,
Paul's
I think
question
so.
and then some. And we have another one here. Do not go away. Adding an air control layer during an exterior renovation.
And our guy is Carl.
This is Carl. Hello, Carl. Carl's in zone 4. So Carl says, we want to create a continuous air control layer on the exterior of our home during an exterior renovation. We will be replacing the windows, vinyl siding, and adding 1/2-inch plywood sheathing covered with house wrap. The house does not yet have sheathing or house wrap, but it does have R4 or 5 foam board on the outside. What language would you ask to be included in a contract so that we can create an air control layer on the outside? Beyond asking for plywood seams to be taped and rolled, I don't know what else to ask for. This is a 1980s 2-story colonial-style home, your favorite, with a vented attic that will never be used as living space.
Are you saying that because you think I was around at colonial times? Is that why you said
No,
that?
not at all. I just know you favor the architectural style of a beautiful 80s colonial.
Okay.
Anyways, yeah, I don't know. So my first question, I'm going to pose questions to
Wait,
you.
I have one. Go ahead. Sorry.
All right. So he talks about it's a renovation, and there's some kind of siding, but there's also some R4 or 5 foam board. Do we leave the foam board on there?
Hell no.
Yeah.
Why is that?
Because you want to get your new structural sheathing right up against the studs.
What about Zip-R?
So would you leave the R3 or 4? Is that
It's
what you said?
R4 or
R4 or 5. Would you leave that and secure the R6 panel through that?
Well, so some of the Celotex, that I'm assuming it's Celotex that he's talking about. It could be that the corners are braced and that there's no need for, you know what I mean?
Yeah. Yeah.
So if it's built in the 80s, in my market, which is climate zone 4, they would have had corner bracing and let-in bracing and then Celotex or foam board over top of that, and the sheathing would have been omitted. and he's adding plywood for some other reason potentially.
Okay, so
you're asking for demo for no reason in my mind.
but doesn't he
I'm
say that
inferring things.
Doesn't he say that they're going to put new?
He says they're adding
They're gonna
half-inch plywood.
They're going to put new plywood, new vinyl siding, and new windows.
And so I assumed the plywood was for air sealing purposes or something, because he mentions taping the plywood.
Okay,
Right.
so we don't know.
So
whether
there's a wrestling with details.
Well, I think there's
there
an
that we don't have.
assessment that's not being dictated here. Is the foam in good shape? So say it's
okay.
R5 foam. Say it's 1 inch of XPS, and it's in good shape.
Yeah.
You could strip off the exterior siding, put your new windows in, put furring strips up, and put your new vinyl siding over that foam, and probably be fine. You
Yep.
could tape
you
that
could,
foam,
you could get
or,
an air control layer
or
on top of that.
put a My Vest or something self-adhered over the top of it.
You could.
So if we add an R6 to the current R45, right? We know there's structural sheathing in there somewhere. We don't know what it is. We also don't know what's in the cavity, and we don't know if it was built in 1980s, climate zone 4.5. We better be sure that there's not a serious interior vapor retarder there.
Correct.
Because we want some drying potential of that existing layer of sheathing to be able to go to the inside. That's one thing.
But if it has R5 foam on the outside, that's XPS, and it hasn't failed yet.
Yeah. So this gets into, I would never work on this project until I knew what the full
Well, you'd have to go.
Yeah.
You'd have to go.
Yeah,
and see
'cause
it.
it's just too
And I
much
don't even
of a
know if we
guessing
would
game.
need even R6. We could get away with R3 here if
Yeah.
the 5 stayed intact.
Yeah.
So what I would say is that getting some layer of this assembly airtight in the field of the wall is going to be easy. I don't care what he tapes, whether it's a zip bar panel or not. It's at the margins and at penetrations where,
Always.
yeah. So to me, I don't care how anal they are, you better do a blower door test.
That's what I was going to say.
Yeah.
I would say he asked specifically
In the
about
contract.
contract language.
Yeah.
So I would ask for a pre-construction blower door
Yep.
test.
Yep.
And a post-construction blower door test. And any builder that's going to be willing to sign on in an informed way for that is going to understand what you're asking for.
Bingo.
And that's like the key starting point here. And that's something that we do with our renovations. Even if there's nothing that has to do with energy involved in the renovation,
But
if we're
I'd
touching
find
the
a
envelope.
Closet or something that's backed up to an exterior wall and maybe core a 4-inch hole to see if there's
You're going
anything
to get to
on
the
backside.
outside. You can pull one piece of
I guess you pull
insulation
yeah,
off and
that's
work
true.
in from
and
there.
Work in and see. But
Yeah, it's interesting. I always love to find a north wall closet on the outside of the building because that's going to be the
worst case.
the worst case.
If there's a problem, that's where it's going to happen.
Yeah.
Why closet? Explain to listeners why closet.
Well, because closets generally have sort of like a microclimate. They're never fully conditioned. It's even more interesting if you do it when it's not a louvered door, because now it's really closed off. So you can, that's a closet on a north exterior wall is like the worst case scenario for you to go look at to see if the home has experienced any moisture problems over the years.
Again, for those of you that are listening in the southern hemisphere, Pete is being northern hemispheric centric.
Yeah, and this is climate zone 4, so
Wow. Yeah,
you know,
you're just like blowing it up on our chili.
Good catch, because our good friend
Chilean
Doug Morgan
Chilean
would
leader-
say,
listeners.
Peter, our problems in zone 4 are not what they are for
For
climate zone
Argentinian
6.
listeners, just forget about them.
So the north side of the building, because the sun doesn't hit the north side of the building.
Yeah.
The closet, because there's not conditioned air being pumped into the closet and people aren't opening it. And if it doesn't have a louvered door, chances are there's stuff stacked against that wall.
I love
the
to
most
also,
challenged.
I can get permission in a closet to pop off the baseboard on that side, measure up 1.5 inches above the bottom plate, and then just poke a little hole and get a sense of what's going on there.
Yeah.
I'm
so
kind of a closet building scientist.
If he has a material that
It's a
can
joke.
be left, in the foam or the Celotex or whatever it is, and we've explored and we know that he doesn't have an interior vapor barrier or he has sufficient insulation in the cavities, and we're adding sheathing. I mean, he might not have to add sheathing. If he's wanting to add it for nail-based reasons or some other reason, fine. I would say it's not necessary, potentially. There's plenty of ways to get there air barrier-wise. If the substrate's going to allow you to do a fully adhered membrane, that's probably the easiest way to get there without adding sheathing, because those are going to be easier to detail than, say, like a Tyvek or something that's mechanically fastened.
Yeah.
Right?
The other thing I want to mention here is that it's such a relief to hear him say that we are replacing the windows, because all of this gets way more complicated and iffy if you're tempted to leave those windows.
You're really a window guy. You love.
I'm fairly transparent about how much I like windows.
But if he's having to replace sheathing or the foam, if he's pulling the foam off, then replacing the sheathing is an easy one. You could go to zip, or you could go to a plywood or an OSB. You could still do a fully adhered, or you could do a liquid applied, fluid applied. You get a monolithic either way.
And I think you're getting at the issue of it's really tempting to leave that R4 or R5 foam board, but I don't know if you're going to yank the windows. You're probably going to end up having to take that off.
Yeah.
Yeah.
So
It depends on how many windows too, because you could just cut around the foam and add a butt to the outside or something and flash it appropriately and call it a day.
But without blower door testing this, what is it that Coda says about your theories without any information to back it up?
Oh yeah, having numbers without like any data is just your opinion.
Yeah.
Yeah. Yeah, I totally agree with that.
So you have to force the hand of the builder to test in and test out to show that they've done something that's going to be an improvement, and you have to get a builder that's going to sign on from the beginning to understand what they're committing to do there. And if you can do that, then you're going to have somebody that knows what the hell they're doing.
I know we've gotten a whole bunch of questions from people about what the heck do I do if I'm in an area of the country where I simply cannot find any high-performance architecture.
We have another
builders.
episode about that.
We'll have to do another
soon.
episode because if you write contract language and you can't find a builder who will do blower door tests, you're really up.
You know
to
what a
creek
really
without
good
paddle.
business model is, I think? If you became a really good builder and you could hire, say, 4 or 5 employees and be like nomadic high-performance builders.
Yeah.
And go around. And like you wouldn't need necessarily the whole crew. You just become the general contractor out there, and you can, work with the local framer. The framer works with your guys.
Interesting.
So you have a guy that works. I don't know.
So I had effectively the same question from an architect that we work with sometimes. It wasn't a project that I was involved with. The architect was like, hey, another builder brought this job into my office. I need a WRB that we can add to this building after they strip it. Do you have recommendations? And I said, well, do you know what's in the wall? And he said, no. And I said, well, if the house was built in the 80s or the 90s and you guys aren't touching it and you're not wanting to get into it, then it has to be vapor open. These are the things that I would use. And he's like, okay, why vapor open? And we had the whole conversation about, well, you can't put a vapor barrier on the outside if it already has a vapor barrier on the inside. 80s or 90s in my market probably has 6 mil poly on the interior side of the wall. This is why. And so without the knowledge of what's going on the inside, it gets way more challenging. So the more exploring you can do beforehand, the better.
And Steve, when you and I work in a building science corporation, you would think that there wouldn't be 6 mil poly in zone 4. But there was. Yeah. And I was going to say the PS is very important.
Yeah.
And from Carl.
Yeah. Well, so that reminds me, I've been trying to find time to tell you. I went to this extremely, what some people might think was a really cool exhibit.
Oh, yeah?
It was on the smallest wind turbines in the world.
Yeah?
Yeah. I mean, they were so small. But, I walked out of there saying, I'm just not a big fan.
Yep.
You continually ask for Steve to continue this, so if
I
you're
can't
having
even tell you
trouble
how
with
many
this,
emails I get where people I listen to the podcast just for the jokes.
I have to admit, I read all the questions that come in, and it's depressing how many people say we really look forward to wrapping up the podcast with one of his gems.
I thought our listeners were better than this.
Yeah, it's just sad.
Yeah, the PS on this one was keep the dad jokes coming. Anything that gets Jake to groan at the end of every episode is worth it.
I mean, I think it's
that's
just
to the heart for you.
I think it's testament to the world that
Thanks,
I
Carl.
have my finger on the pulse of the world, and you guys just fail to admit it, and that's fine. That's fine.
I can't wait till you flatline, basically.
Because if people, you've heard I forget, I don't know if it was Ben Franklin or somebody, but like, if you don't have a few people out there mad at you or making fun of you, then you're not, pushing the limit. So, hey, you guys keep pushing. I'll do my thing. The fans love it. Obviously, they're coming to hear the jokes.
I would like to point out how big of a person I am that
You've read.
I let this question go through even though it ends that way.
Here.
So,
Yeah.
Jake has big shoulders.
Carl, thank you for your question.
All right. Well,
Wrap it up, Steve.
There you are. I'm not going to say Atlantic to the Pacific. I'm going to say, hey, we just went around the equator. We came to the whole world. We brought you the UnBuild It podcast. This is Steve Basic. I'm signing off with my good friends Jake and Pete. Stay tuned. We got another one coming in a couple weeks.
See ya.
Have a good day.